from Science WASSCE 2016 test of practical work. We want to look at this question. Question 3, which is a graph work. We want to solve it in order to assist students. Now the question reads, figure 3a, that is this one, is an illustration of an electrical circuit diagram used to investigate the relationship between the current I flowing through a wire Z and the corresponding voltage drop V across the wire when X is adjusted. The voltmeter reading V and the corresponding ammeter reading I were noted and recorded as in the table below. So you have seen this. Figure 3b shows the ammeter reading I2, I3, that is current 2, current 3, for their corresponding voltage reading 2.1 volt and 4.0 volt. So the diagram is given. We have to analyze the question. Then the table was given. This is the ammeter, and this is also another ammeter. That's ammeter. This is, you have it measures the current. Here also current is being measured. The ammeter measure current. Is an instrument that measure current. So here the first question read, identify apparatus X. B, copy the table, read and record the value of I2, that is current 2, this ammeter, and I3, that is this one, they are reading. Now see Roman figure 1. Using the figures in the table, plot a graph of V on the vertical axis and I on the horizontal axis. Roman figure 2. Determine the slope of the graph. Let us see Roman figure 3. From the graph, state the relationship between I and V. Let us read the question again. Figure 3a, that is this one, figure 3a, is an illustration of an electrical circuit diagram used to investigate the relationship between the current I flowing through what? A wire Z. The wire is given here, which is Z, and the corresponding voltage drop. So voltage is also given, and voltage is measured by an instrument called the voltmeter. So across the wire, when X is adjusted, now X is here. If X is adjusted, it's trying to tell us that this is a variable resistor, because variable resistors can be adjusted. If it is a fixed resistor, it cannot be adjusted from the manufacturer. But if it is a variable resistor, that one can be adjusted. So if X is adjusted, the voltmeter reading V and the corresponding ammeter reading I were noted and recorded as in the table below. So this is the table that is given. If we look at the table, we have the voltmeter reading. So the voltmeter reading, which is in volt, it measures the voltage. We have 1.0, the other one 2.1, 4.0, 5.1, 7.2, 9.0, 10.1. Ammeter reading, that is for current 0.17. We have I2, that is current 2, I3, current 3, which need to be recorded. Yes, the current need to be recorded. Let's see, in ampere, which is the unit. So we have 0.60, the other one 0.95, other one 1.08, and 1.20. So here this is I1, I2, I3, I4, I5, I6, I7. The same thing here. V1, then you have V2, V3, V4, V5, V6, V7. So we have current 2, that is this one. We have to find it out. And current 3. So these are the ammeters. They measure the amount of current. Now identify operator X. From here, since X can be adjusted, we should know that is a variable resistor. Now we look at it. We have the question here. We have to put down our answers. Identified operator X. We write what? Variable resistor as our answer. We all know what resistor is. It opposes the flow of current. Resistor. So variable resistors can be adjusted. Yes. The next one, copy the table, read and record the value of I2 and I3. That is, from here we need to determine I2 and I3. Now the simplest way to determine this one, we use a technique here. So you look at it, you need to know each line is giving you what unit, in what unit. So here you count all the lines where you have the first number, you divide it, it will give you the unit for each line. So here the first number here is 1. What we do, we say 1 divided by total number of line, to this one. So here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 10. We know that this should give us, it's very simple, 1 divided by 10, we have 0.1. So here simply mean each line is 0.1. Now we look at where this one is pointing, the pointer, we record it. So here we have 0, 1, 2, 3. Resume is pointing at 3. It's much closer at 3. So then what do we do? These 3 we have to multiply by, because each line is 0.1. So we have this multiplied by 3. 0.1 multiplied by 3, we have 0.3. So for our I2, we'll have it as 0.30. Yes. Then from there, the range can differ, because depend from the way the candidate analyze it, but it's much closer at 3, because when you look at the arrow, you may not know where it is pointing exactly. But this one is very specific. It's the same thing, the same ammeter. So here we have it. Each line, we have to understand it. Each line has a unit of 0.1. So this is 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. So as a result, I3 will give us 0 0.50. That's our current reading from this ammeter. Yes, we have completed the table. Now CI asks us, using the figures in the table, plot a graph of V on the vertical axis and I on the horizontal axis. So here we are asked to plot a graph. We cannot answer this question without plotting the graph. So before we plot the graph, these things need to be noted. Points to be noted in plotting a graph. Steps: draw the y-axis vertical and x-axis horizontal. So the y-axis in vertical, but since here we are given voltage and current, we can use those ones instead of the putting y-axis there. But we have to understand that the y-axis is the vertical here, the x-axis is the horizontal. Yes, so here the next one, label each of the axis with the units. Like example, you put what, you have to indicate the names. You put what, voltmeter reading in this side in volt, which is the unit. On this side you put what, current in ampere. So you need to take note of that as you are plotting your graph. Choose simple scale units based on the figures given from the question with a uniform interval. So from the question that is given, that's where you choose your units, because some of the figures can be high, some of them can be at a very low figures. So in choosing your scales, you have to be very much careful. Like for instance, the interval also has to be uniform. Here we have 2, you see, you add another 2, you have 4, you add another 2, you have 6. So it has to be, or you have 5, 10, 15, or so your scales must be uniform. Yes, so 4, choose a scale which will allow the graph to cover as much of the piece of the graph paper as possible. So the scale that you choose is, you choose numbers that you know at least it will cover almost part of the graph paper, because in case if you are given higher numbers, you happen to choose a similar scale, your graph might stop here, which is not good. So you need to consider that when choosing your scale. No need to start from 0 if the points lie, for instance, between 80 and 100. Take note of that. It depends on the numbers that are given. If the figures given start from 80 to 100, there is no need for you to start from 0. Yes, to start at 0 will cramp your graph into a small section at the top. Yes, so you need to take note of that. Plot the coordinate, then you plot your coordinate from the figures given. You take note of that. Join the points at once using a ruler. Do not allow